wanted me to, a client wanted me to create a secure messaging client for them. So I installed MySQL and Apache on a Windows server. Thought that was good. I told the client that it would be down 3 hours a month for upgrades. Since my goal was to have a 98% utilization, which is 14 hours down, I was at 99.5%. I thought that was good. Client wasn't so happy. So I went to Linux instead of Windows. 1 hour down, 1 hour every 2 months, and now we're at 99.9% uptime. So we launched the application, and then we start to do pilot testing, and one day the hard drive fails. We're down for a whole day. Client was quite unhappy. So after we could just get one more server and database on more than one power grid, but then we're getting a higher cost after writing up a couple options. The client opts to go with a cloud deployment, so to AWS we go. This will take care of updates, so now we should be at 99.99%. We're down for about 4 minutes a month. And I've separated the database and the web server. That's how it works better in AWS. So we go back to pilot testing, and everything is fine. So the client is happy, and then we start beta testing with 10,000 users. After 3 days, some of the testers informed the client that they're getting connection errors and internal server errors, so there was a problem. I looked into it and realized there are too many connections for one server since there is one database and one web server. So I turned on auto-scaling, and now we have multiple web servers automatically. But 3 days later I get notified about errors, and now the one database is a problem. So we have multiple servers here, and these scale up and down as we need, but we still have one database. That's creating problems. There are too many database connections to the database. So then we get into, I need to have a distributed database. But now we have Brewer's theorem to consider. So you have, if you're a distributed database, you have partition tolerance. So you can be on multiple locations. So you get to pick one of these two. You either can have consistency or availability. If you pick availability, then if that's your high priority, then that means that not all the nodes will always have the same data, that there will be a time where the data is getting updated from node to node. If consistency is important, then you'll reduce the availability because while it's replicating this data, you won't be available. So I decided to go with the AP because so we are eventually consistent. So now we have multiple databases, or it's actually one database, but multiple nodes or servers. So it takes care of the problem. And any of the web servers can be connecting to any of the other nodes. So we don't have the connection problem that we used to. So I have a happy client, and I'm going to take a world server vacation, and the client understands that sometimes there might be, when you connect and you want to get messages, there might be a message waiting on one node, but the node that you're pulling the information from isn't there. Eventually you'll get your message. So there could be a delay. So that's my final design. But then, as I'm getting ready to go to the beach, I'm packing up, I find out that people are sometimes getting errors, and I look into it, and I find out that sometimes a VM just disappears, and my application crashes for the client because I was connecting to a particular node. When it goes down, I had assumed that the information was still there, and I have a problem. So I could use multiple web servers in a chain, and so I could break up what I'm doing and just have where, in case the middle one goes down, for example, then some of the other ones should be up, and as long as they can connect to all the other ones, so I could have multiple in the first row, multiple in the second row, much like I do with the database. But that's still fragile because if this first one breaks, I'm still down. So I started looking at the fact that I'm using client-server. So the problem with client-server is that, for example, if I'm trying to get a token, the person's already logged in. Now they need to actually get the token so they can verify to the server that who they are. The browser calls, gets information, and then this login controller calls a DB service, and then we go to get the user from the database, and then we select the user by name, and that comes back. But at the same time, we're also retrieving a password, and then, so these two things happen at the same time. And then, so we're also selecting password by username, so we make two calls. But validate, and then all this information has to flow back. Validate answers has to wait till both of these are received, then it can validate, generate the token, and return it all back. So everything, all the data flows, you reach a certain level, the response has to be passed back. That's the client-server approach. And then I look at the fact that when I did Smalltalk a long time ago, I realized I was passing messages. I wasn't calling methods. So I was isolated from these issues because if I pass a message for retrieve user, if that fails, then the controller actor would know, and I could just pass another message. Easy. So I just need to find some sort of messaging scheme, but I don't want to use an enterprise service bus. An enterprise service bus is basically you make a connection, and then it just keeps calling these different web servers and does their task, and databases could be in there, it could be different servers, but each of these branches introduces latency. So that would be too slow for the user. So I go back to Google and I learn about Akka. So Akka is a Java library that seems to solve my problems. You pass messages to actors, and each actor does a very specific thing. But if an actor crashes, then you can restart them, you can do whatever you need to do in order to keep everything going. So after a week of hard programming, so the way that the actors work is, for example, I'm getting a token, I call here. I call this actor. Now this actor also has a supervisor, so I call and I get the token actor. I pass the information for that. And then it retrieves the user. And it just keeps going through, passing messages. If one of these fails somewhere, so if I call the database and I can't for some reason make a connection, then the user DAO, the select user by username will fail. And then one of these others, probably in DB service, will catch that the user DAO failed, and it will just send it again. And I might have it set up to where it might retry it 5 times, and then it'll have to pass up and say, yeah, I can't connect to the database. But then, the other nice thing about these messages is, for example, in the user DAO, when it gets its response back from the database, it doesn't send it to the other 2 actors that the information had flowed through. It goes directly to the login controller. That's the other part, is that this is no longer client server, now I'm just passing messages to whichever actors. And then I just make more calls down, I generate the token, and then I actually pass the token back. And so this is the way that the login would flow. And then I run into a problem where about Docker, because someone had changed the code on the AMI, but it isn't the same as in dev, and I expect it isn't the same as what's in production. So I have to work around these smart types. I want to make infrastructure changes willy-nilly, and look at Docker, which is a container. I can put my web services on Docker image, and AWS knows how to start these up, and the exact same version of my infrastructure goes to different environments, so no more surprises. So my final solution, I've used a distributed database with Docker on the server, and the web server is in a Docker image. So I have Jenkins create the image every time I put code into Git, and I can safely deploy my changes to the environments with no surprises. So it's a message-based, resilient, responsive, and elastic application. And now I have a reactive application, so I can head out for sun and surf.